Okay. Everybody can hear me okay? Yeah? Yes. All right, cool. So here's our exam from last time. We need to solve for x here. So first thing we notice is there's x's all over the place. We need to get all the x's together, okay? So these parentheses are mildly infuriating. So let's get rid of the parentheses. So this equation is equivalent to the equation where I distribute the 3. So 3 times 2 is 6, and then 3x. So these are logically equivalent equations, okay? So now let's get all the x's together. I could subtract 2x from both sides. If I did that, I would just 1 equals 6 plus x. Okay. Now we need to get the x by itself. So let's subtract 6 from both sides. And I get minus 5 is equal to x. And that's it. Had any questions about that one? It's going to be done the same way. It has fractions, so that makes it kind of a pain in the butt, but we can still handle it. We're going to get a new equation here. We'll keep it the way it is, but we have to distribute the 1/2 across. 1/2 times 2, 1. 1/2 times 4 is 2. All right, so all he did was distribute the half to get rid of the parentheses. So now, just like up at the last problem, we need to get these x's together. So if I subtract 2/3 x from both sides, I will get 1/2 equal to 1 plus, since we're trying to add these, right? We kind of need a common denominator. I could write 2x as 6x over 3. Okay, so I just rewrote 2x as 6x over 3. We have, at this point, we can do another step here. We're going to combine these, but we also want the x to be by itself. So let's get rid of this 1. We'll subtract 1 from both sides. So on this side, 1/2 minus 1, negative 1/2. Over here, these cancel. 6x minus 2x is 4x over 3. Okay. Now, you could do this in 2 steps or 1. All right, you could divide both sides. I could divide both sides by 4 because I want to get rid of that 4. And I could multiply both sides by 3. I want to get rid of that 3. Get rid of the 3 and the 4s. Now I have x equals negative 3 times 1 is 3, 2 times 4 is 8, negative 3/8. All right, any questions? All right, let's do a quiz then. Solve for x. Do 1/3 minus 2 2x plus 1 equals x plus 1/2 2x minus 1. Okay, and we'll do, I'm going to show you a trick here. We'll do 1/6 times 2x minus 3 plus 5/6 equals 2/3 and x minus 1. Okay. So a tip on something like this, if I just multiplied everything by 6, I'd get rid of all the fractions. All right, so that's a tip. You could do the same thing here. You multiplied everything by 6, all the fractions would go away. All right, so we'll take 10 minutes at 2:15. We'll work this together. Okay, folks, I was just looking at your grades. Seems like about only half of y'all bothered to turn in the daily quiz. And it's 30% of your grade and it's free, right? We work it in class every day. So please turn in your work. You know, you don't want to have to take this math class again. All right, let's look at this quiz here. So we have x's all over the place, right? And we have parentheses. We need to get rid of the parentheses and consolidate our x's. I'll show you a trick though. Let's get rid of the fractions. Watch this. I'll multiply both sides by 6. Why 6? Because 3 and 2 both divide into 6. See, when I multiply 6 by 1/3, I get 2. And then the 6 times 2 gives me 12. I still got this thing. 6 times an x gives me 6x. 6 times 1/2 gives me 3. So no more fractions. Multiplied everything by 6. Now let's get rid of these parentheses. 12 times 2 is 24. And 12 times 1. 3 times 2 is 6. And 3 times 1 is 3. So now we can combine like terms. 2 minus 12 is -10. 6x and 6x, so there's 12 x's. So now let's get our x's all together. I could add 24x to both sides. Okay, so these x's are going to go away. I'm going to have x's right here. So let's also get rid of this 3. Okay, well, this goes away. -10 and 3 is a -7. 12 and 24 is 36. And then the 3's went away. And now we just need to divide both sides by 36. So x is -7 over 36. Can y'all handle that? I know there's a whole lot in that problem. All right, number 2, I would do the same thing I did up there. Get rid of these fractions. And I have a question. Was the 6 to everything or only the fractions? We have to multiply everything, right? So look, I'm going to multiply everything on the left-hand side and everything on the right-hand side. Okay. So if you look at this, the form of this is like 6. This is a number. This is a number. And then this is a number, right? So this right here has this form. So we need to multiply this across. We get a 6AB and then a 6C, okay? What we get up here is 6 times 1/6 is just 1. And we're left with the 2x minus 3. I can leave it, go ahead and put the 1. Okay, and then we have 6 times 5/6 is 5. Okay, that's how that works. This is a thing. This is a thing, right? And there's a plus between them. It's 6 times this thing and 6 times that thing. And basically here the 1/6 absorbs that 6 and just turns it into a 1. And then here the 6 times the 5/6 just leaves us with a 5. And over here we're multiplying these all together, right? This is the same thing. I don't even need parentheses here. Right? They're not doing anything. This is A times B times C, where this is A, this is B, and this is C. Okay? Which I can multiply in any order I want. I'll go ahead and leave these parentheses here though, just for emphasis. Now 6 over 3 is 2, and 2 is 4. Okay? And again, I don't need 1 here. 1 times that. That's just what it is, right? I'll leave it for now. Doesn't hurt. Let's just drop these parentheses. Over here, we'll distribute our 4 across. We have 2x. 5 minus 3 is 2. Now we want to get our x's together. If we subtract 2x from both sides, this will go away. Our x's will be here. Let's get rid of this 4. Okay, so 2x minus 2x, it goes away. 4 plus 2 is 6. 4x minus 2x is 2x. And the plus 4 minus 4 goes away. So now we can divide both sides by 2. 6 divided by 2 is 3. Okay. So these were harder, you know, but y'all can handle it. It just takes practice. Okay, so we're in 10.2, example 5. We're going back to some real simple ones. Okay, you get lots of practice with the easy problems. On the quizzes, I like to do harder ones because I'm going to work them for you, you know.
In this video, we have the equation 6.8c minus 2.7 equals 1.2c plus 58.9. Neither side of the equation can be further simplified. I'll move on to step 2. I'll collect the variable terms on one side. I'll subtract 1.2c from both sides. I have 6.8c minus 1.2c minus 2.7 equals 1.2c minus 1.2c plus 58.9. Simplifying, this is 5.6c minus 2.7 equals 58.9. I'll add 2.7 to both sides to isolate the term containing c. We have 5.6c minus 2.7 plus 2.7 equals 58.9 plus 2.7. I now have 5.6c equals 61.6. I'll divide by 5.6 to obtain a coefficient of 1 in front of c. So c equals 11. I've already done the check, so the solution set is a set containing 11.
Okey-dokey. So let's do these. All right, so we want to solve for y in this case, and there's y's everywhere. So let's get all our y. Can we do this one? Before we've done this one. That's okay, we could do it again. We need to get our y's all together, so let's subtract this 2.2y from both sides. If we do that, we got a negative 8.3. 6.2 minus 2.2 is 4. So now our y's are consolidated. Let's get rid of this 12.1. That gives us a 4y is equal to the 12 and 8 is 20 negative. So now dividing both sides by 4, y is 20.4 divided by 4, negative 5.1. All right, this one we're solving for t. So let's get all our t's together. I'll get rid of 1.5t from both sides. That goes away. We're left with 2.3. 3.5 minus 2.5 is 2 t's. Now let's get rid of this 1.9. So I'm left with 2t is equal to 2.3 and 1.9, that's 4.2. Now divide everything by 2. T is equal to 2.1.
Here we have another linear equation to solve. 1 minus 2x minus 4 equals x minus 5 times the quantity x minus 7 all plus 4. I'll simplify each side separately to make the equation simpler. On the left, I'll collect like terms. 1 minus 4 is negative 3. So we have negative 3 minus 2x, and this is equal to x minus 5x plus 35 plus 4. So this is negative 3 minus 2x equals negative 4x plus 39. I'll add 4x to both sides. So negative 3 minus 2x plus 4x equals negative 4x plus 4x Simplifying this gives us -3 plus 2x equals 39. I'll add 3 to both sides to get -3 plus 3 plus 2x equals 39 plus 3. So 2x equals 42. And dividing by 2, we have x equals 21. I've checked the answer, and it satisfies the original equation. So the solution set is a set containing 21.
Okay. Okay, let's see here. There's X's all over the place. That's okay. First thing we're going to do is combine this 2 and this 5. Get -3. And let's get rid of these parentheses by distributing this 6. So leave that alone. Let's combine these to give us 8x. Now let's get our x's together. If I subtract 7x from both sides, I get this. Right, that goes away. And now I'll subtract 18 from both sides. X is equal to, what is that, -21? Yeah. All right. Number 6 here, let's get rid of the parentheses. Times 2 is 8 minus 4 plus y. Let's combine the 6y minus y, get this 5y. We can combine these y's to give us 9. Now let's get the y's all together. We'll subtract 5y from both sides. That gives me what, 4y minus 4 equals 3. Now to get the y's alone, we'll add 4 to both sides. We got a 4y is 7. Divide both sides by 4. Y is 7/4. This one, there's z's all over the place. 1, 2, 3, 4. That's okay. Who cares? Distributing the minus sign. A negative is a positive. One thing that we can do while we're at it, actually, I see z, 4z and 4z. Let's just go ahead and subtract that from both sides. Now this gives me a minus 5z, minus 10, and a minus 6. All right, now let's get stuff together. 9 and 3 make it 12. And then the 10 and the 6 will be 16. Let's get all the z's together. Add 5 to both sides. So I got 5z minus z is 4z. I still have this 12 hanging around. And then minus 16. So let's get rid of the 12. And the 12. Give me 4z equals -28. Now I can divide by 4. Z is -28 over 4. That's what is that, -4? No. How many times is 4 going to 28? 6, 7, right? 7 times 4 is 28. Yeah, that's right. Any questions? Okay. Look at all those X's. That's okay. I see some X's here. Let's get rid of those. All right, that'll get rid of that. And we can get rid of these parentheses too. Distributing the minus, we got a minus X and a minus 5. 6X minus 3X gives me 3 X's. A minus 5X, a plus 5, and a minus 3. All right, let's combine our like terms here. The 10 and the minus 5 give me 5. That gives me negative 2x, and this gives me 2. All right, let's get our x's together. I'll add 2x to both sides. That goes away. And I'll subtract 5 from both sides. That goes away. The 2x minus x is x. Over here, 2 minus 5 is a negative 3.
In this video, I have 3 equations. The first equation is 2x plus 4 equals 11. I'll start by subtracting 4 from both sides. I have 2x plus 4 minus 4 equals 11 minus 4. This is 2x equals 7. Dividing by 2, we get x equals 7 halves. And by the way, there's nothing wrong with getting a fraction as an answer. You'll see that the solution checks. I'll substitute 7 halves for x. And 2 times 7 halves gives us 7. And 7 plus 4 equals 11. This equation has one solution, and we say that the equation is a conditional equation. This is because the statement is true on the condition that x equals 7 halves. In the second equation, I have 6x minus 5 times the quantity x minus 1, all equal to x plus 3. I'll simplify the left-hand side. I have 6x minus 5x plus 5 equals x plus 3. Simplifying further, I get x plus 5 equals x plus 3. Now I'm going to stop here. I've got the same number x on both sides, but I'm adding 2 different numbers to it. So the left and right-hand sides can never be equal. There are no numbers x that can possibly work. Furthermore, if I subtracted x from both sides, I get 5 equals 3. This is a contradiction. And we have no solution. The last equation is 4 times the quantity x minus 2 equals x minus 8 plus 3x. Simplifying, we get 4x minus 8 equals 4x minus 8. Well, the 2 sides have identical expressions, so it looks like any number I substitute for x would make the two sides equal. If I continued solving the equation by subtracting 4x from both sides, we'd have the identity -8 equals -8. If we add 8 to both sides, we'd have 0 equals 0. So any way we look at this, we have an identity. And with an identity, the solution is a set of all real numbers.
So we use the equality symbol in a lot of different ways. And you kind of have to understand from context what they mean. Like conditional equations like this one, it's only true in the condition that x is 2, right? Otherwise, it's not true. Something like this, you can see if I subtracted x from both sides, what this thing is saying is that 1 equals 2. All right. So they call this a contradiction because, well, its solution set is nothing, right? I mean, it's not any different than this one. It's a condition. This is a conditional equation. It's just that there is no condition that satisfies it, so they call it a contradiction. Sometimes we'll use, like, you've seen me use like a triple equals, or I might use a dot equals. One thing to say, when does this equal that? It's kind of like a question mark equals, right? Or if I'm defining something, like define D to be the number of dogs. So sometimes you'll see these, or you'll see an equation like in trigonometry, we do this: cosine squared plus sine squared equals 1. This is an identity because no matter what number you plug in here, it's always equal to 1. So we have other equations that are called identities. And that's basically meaning the conditions that make this true is any number. Like this, here's one: x equals x, right? Obviously, what conditions make that true? Any number you want, so you could call this an identity. Or x equals x squared over x, right? X squared over x is x. These are always equal. Of course, here you can't let x be 0. You can't divide by 0, even if it is 0 squared over 0, right? So there's different kinds of equality, but we use just the same equal symbol all the time. It's kind of frustrating. Oh, here we go, identities. All right. So x plus 4 is always x plus 4. They're identical. Or the identity, the solution set is everything. So we want to look at these equations and figure out, are they conditional, contradictory, or an identity? Okay. So basically, you try to solve for whatever their letter is. Here it's K. So let's get rid of these parentheses. By distributing, we get 4K minus 6 plus 1. All right. Right here, you can see that you can subtract 4K from both sides. And simplifying that, we have minus 5 equals minus 5. All right. This is an identity, because no matter what number you plug in, both sides are equal. Look at the second one here. Let's distribute this 2 to get rid of these parentheses. And right here, you can see I could subtract 2b from both sides. This says -8 equals -7. It's a contradiction. It's never true. There are no solutions. There's no number you can plug in here where both sides will be equal. All right, this one, let's see, let's subtract 2x from both sides. So we get x plus 7 equals minus 5. Subtract 7 from both sides. We have x equals negative 12. So this is conditional. This equation is only valid when x is minus 12. Okay, let's see this one. Let's get rid of these parentheses. 4 times 2 is 8. 4 times 1 is 4. Right here, I can look at this and say I can subtract 8t from both sides. 4 minus 1 is 3. 3 equals 3. An identity. No matter what number I plug in for t, both sides of this equation are going to be equal. Pick a number. Let's try 0. If I make that 0, that's gone. I just have 4 minus 1. So this side is all, it'd be 3. Over here, if this is 0, I got 3. 3 equals 3. See, it doesn't matter what number I plug in for t. Both sides of this equation are going to stay the same, are going to be equal. Because this equation is logically equivalent to 3 equals 3, which is always true. Let's see this one. I got a 3x minus 5. I'll combine these. I got a 3x plus 1. Obviously, I could subtract 3x from both sides. Well, minus 5 is never equal to 1. So it's a contradiction. All right, this one, let's get rid of the parentheses by distributing that 6. Now let's get our v's together. Gives me a 4v minus 12 equals negative 4. I'll add 12 to both sides to get that to go away. Let's see, 12 minus 4 is 8. So v equals 2. This one's conditional. It's only true when v is equal to 2. And that's it for 10.2. Let me see where we're going next. 10.3, okay. So y'all need to do the Alex homework for 10.2 now. Make sure you have it done. Start working on 10.3, okay? Linear equations containing fractions. Okay. Oh, we kind of already did this in the quiz today, right? I don't know what all this says. Let's work an example. So the trick here is getting rid of the fractions, right? If you can, it's not always doable, but if you can, try to get rid of the fractions first. See, if I multiplied everything by 6, this would turn into a 2. I get a 5, but I'd still have a fraction here. So 6 isn't going to work. If I multiplied everything by a 4, this would just be a 3, but I'd have fractions here and here. So what number can I multiply that will get rid of all these fractions? I need the smallest number that all 3 of these will divide into. In which case it's 12. 6, 4, and 3 all divide into 12. If I multiply both sides by 12, All right, let's look and see what happened. 12/6 is 2 times 5 is 10. 12/4 is 3 times 3 is 9. Then 12/3 is 4. Boom. The exact same equation. I just made everything 12 times bigger. So now we'll add 9 to both sides. We have 10x equals -5. Divide both sides by 10. 5/10 is 1/2. This guy down here, this is a shortcut of notation I'm going to do here. Multiply everything by 10, right? I think it's obvious what I mean when I do that, okay? Instead of doing two sides separately, this is my shortcut personal notation, all right? But I think it should be adopted by standard math community. It's clear, it saves like writing. 10/5 is 2 times 2 is 4. 10/2 is 5. 10/10, the 10's cancel. Boom. Now let's get our y's together. So 4y equals -12. Get rid of that 4. The y is -3. Boom.
In this video, we'll solve the equation 2/5 x minus 3/10 equals 1/2. Now, to isolate the variable, we can add 3/10 to both sides, and then to get a coefficient of 1 on x, we multiply both sides by the reciprocal of 2/5, which is 5/2. This process is not difficult, but because of the arithmetic involved with the fractions, we run the risk of making a computational error. So what I'd like to do instead is show you a procedure called clearing fractions. What we're going to do is multiply both sides of the equation by the least common denominator of all terms in the equation. So the least common multiple of 5, 10, and 2 is 10. Now I'll multiply the left-hand side by 10. Then I'll multiply the right-hand side by 10. I'll apply the distributive property on the left. I have 10 times 2/5 x minus 10 times 3/10 equals 10 times 1/2. The reason I chose to multiply by 10 is because each denominator divides evenly into 10. 5 goes into 10 twice. So we clear the fraction. 10 goes into 10 one time. And on the right, 2 goes into 10 5 times. We're now left with the equation 4x minus 3 equals 5. This is much simpler to solve than the original equation. At this point, I'll add 3 to both sides. We have 4x equals 8. And I'll divide by 4 to get x equals 2. I've done the check, and we see that x equals 2 does work. So I'll write the solution set as a set containing 2.
Okay. Notice they always check their work. You always check your work. Okay. So this guy has a bunch of stupid fractions, and we all hate fractions. So let's get rid of the fractions. What's the smallest number that 6, 3, and 5 all divide into? What, 1830? I think we're going to need to multiply by 30. All right? Yeah. Multiply everything by 30. 30. There we go. Third time's the charm. 6 goes into 30 5 times. 30 over 3 is 10 times 2, 20. 30 over 5 is 6. And then 30 times 1. So that's a nicer equation, right? Let's get all our x's together. Since this is bigger over here, I'm going to put my x's over there and subtract 5x from both sides. So this is going to be x. So let's get rid of this 30 and move it over here. Oops, add 30 to both sides. So 30 and 20 is 10. 6x minus 5x is x. Here, let's see, what number can we multiply everything by? 10, 20. 20 will work. All those numbers divide into 20 evenly. We multiply everything by 20. 20 over 5 is 4, times 2 is 8. 20 over 2 is 10. 20 over 4 is 5, times 7 is 35. 20 over 10 is 2, and 3 is 6. So since my x's are bigger over here, let's get rid of this 6x. And since my x's will be here, let's get rid of this 10. 8x minus 6x is 2x's. 35 and 10 is 45. So x is 45 halves. This one, we got a 3 and a 2. We'll multiply everything by 6. So 6 times this thing, 6 over 3 is 2. Now this thing, 6 over 2 is 3. And then 6 times 4 is 24. Now let's get rid of the parentheses. All right, let's combine our like terms. 2x minus 3x is a negative x. 14 minus 3 is 11. Let's subtract 11 from both sides. Negative x equals 24 minus 11 is 13. Multiply both sides by minus 1. There you go.
In this video, we'll solve the equation 1/3 x minus 5/6 equals 3/4 x plus 2. I'm going to clear fractions by multiplying both sides with the least common denominator of all terms in the equation. Also, let me write the whole number 2 as 2 over 1. The least common denominator of all the fractions is 12. I'll multiply both sides by 12. Notice I'm enclosing both the left and right-hand sides in parentheses. Now I'll apply the distributive property. I have 12 times 1/3 x plus 12 times negative 5/6 equals 12 times 3/4 x plus 12 times 2. denominator divides evenly into 12, thus removing the fractions. On the left, I have 4x minus 10 equals 9x plus 24. Now the equation is free of fractions. I'll subtract 9x from both sides, and this gives us negative 5x on the left minus 10 equals 24 on the right. I'll add 10 to both sides to get negative 5x equals 34. I'll divide by negative 5 to get x equals negative 34 over 5. The check for this equation is pretty miserable. In fact, we'd probably be better off resolving the equation to check our work. So I'll write the solution set as a set containing negative 34 over 5.
All right. Another one.
In this video, we have the equation 1/2 times the quantity x minus 3 plus 1/7 times the quantity x plus 1 all equal to 1. I want to clear fractions, but first I'm going to clear parentheses. I have 1/2 x minus 3/2 plus 1/7 x plus 1/7 equals 1. At this point, I'll multiply both sides by the least common denominator of all the fractions. So I'll multiply by 14. I'll distribute 14 to all terms on the left-hand side. I have 14 times 1/2 x plus 14 times negative 3/2 plus 14 times 1/7 x plus 14 times 1/7. This all equals 14 times 1. Simplifying, I have 7x minus 21 plus 2x plus 2 equals 14. I'll combine my terms on the left to get 9x minus 19 equals 14. I'll add 19 to both sides, and this gives us 9x equals 33. I'll divide by 9, and we have that x equals 33 over 9. The solution checks. I'll write the solution set. Now, I just want to mention that the reason I cleared parentheses first before multiplying by 14 is to avoid a common mistake that many of my students make. If I had multiplied by 14 first before clearing parentheses, and let me write that here, I would only multiply the 14 times the factor 1/2 and times the factor 1/7 out in front of the parentheses. I wouldn't actually multiply 14 by the terms inside the parentheses. What would happen instead is that I get a new number in front of each parentheses. we now have 7 times the quantity x minus 3 plus 2 times the quantity x plus 1 equals 14. Now I would clear parentheses to get 7x minus 21 plus 2x plus 2 equals 14. And you can see that this is the same equation we solved earlier.
Okie dokie, let's see. Let's take a break, y'all. It's 3 o'clock. Oh. Break. We'll resume at 3:13. How's that? We are back. Let's see, where did we leave off here? Did we do that one? 5Z, 1, 2? No, okay. Another example. Get rid of the fractions. We're going to need to multiply everything by 20. Because both 5 and 4 divide into 20 evenly. 20 over 5 is 4. 20 over 4 is 5. 20 times 2 is 40. If this is messing with you, just because there's stuff here, think of this as like A, and this is B. This is 1/5 A and 1/4 B. The 20, right? If you have 20 times 1/5 A, well, this is 4 A's. It's just that the A here has a longer name. It's called Z plus 1. All right, still just a number. Okay, so here do our distributive property. We have 4Z plus 4 plus 5Z plus 15. Combine our Z's. Combine our constants. All right, let's subtract our 19. Is that 21? So Z is 21 over 9, which we can simplify. 7/3, dividing the top and the bottom by 3. All right.
In this example, we'll solve the equation x plus 3 over 3 minus the quantity 3x minus 1 over 2 equals 1. The least common denominator is 6. So I'll multiply both sides by 6. I'll apply the distributive property to get 6 times the quantity x plus 3 over 3 minus 6 times the quantity 3x minus 1 over 2. This equals 6 times 1. Once again, the reason I chose to multiply by 6 is because the denominators of each fraction divide evenly over 6. And notice that with each term, I'm grouping a 2-term expression within parentheses. The reason is that in the next step, I'll distribute the factor in front to both terms inside the parentheses. Now I have 2x plus 6 minus 9x plus 3 equals 6. Combining like terms, I have negative 7x plus 9 equals 6. I'll subtract 9 from both sides, and I have negative 7x equals negative 3. Dividing by negative 7, we get x equals 3 over 7. The solution checks in the original equation. We'll write the solution set as a set containing 3 sevens.
Okay. Here we have fractions again. This is the same thing as if I wrote 1/5 x minus 2 minus 1/2 x minus 4. It's identical. This is just like the problems we've just been doing, but they're just writing it different, right? This is the same as that, okay? But if we multiply everything by 10, we can get rid of the fractions. 10 over 5, 2. And then 10 over 2 is 5. 10 times 2 is 20. Get rid of the parentheses. We can subtract 20 from both sides. Combine our x's. Move our 4 over by adding 4 to both sides. Now divide both sides by negative 3. Here we can get rid of, we multiply by what, 12? Yeah. 12 over 4 is 3. 12 over 6 is 2. Get rid of our parentheses. Combine like terms. Subtract 7 from both sides. Divide both sides by 5. All right, any questions? Well, now we're going to do the same thing with decimals, okay? Use the same procedure to clear the decimals, all right? So let's see. If I multiplied everything by 10, the decimals goes away, right? 2.5 times 10 is 25. 3 times 10 is 30. 1.7 times 10 is 17. And 6.6 times 10 is 66. Boom, no more decimals. Get our x's together. 25 minus 17 is what, 8? Let's get our x's by themselves. So x is negative 96 over 8. Whatever that is, you can simplify it. Number 5, same thing. If I multiply everything by 10, 1.2 times 10 is 12. 3.5 times 10 is 35. 2.1 times 10 is 21. All right, let's get our w's together. And let's get the 35 away from our W's. 12 minus 10 is 2. 21 minus 35 is what? Negative 14. Divide both sides by 2.
In this video, I'll solve the equation 1.6x plus 2 equals 0.05x minus 10.4. I'm actually going to solve this two ways. First, I'm going to use our standard procedure to isolate the variable. I'll subtract 0.05x from both sides, and this gives us 1.55x plus 2 equals negative 10.4. I'll subtract 2 from both sides, and we have 1.55x equals negative 12.4. I'll divide by 1.55 on both sides, and we get x equals negative 8. Now, another option we have is to clear the decimals first, so that the coefficient of each term is an integer. I'm going to multiply both sides of the equation by a power of 10. It is by 10, 100, 1000, and so on. The choice I make is dictated by the coefficient that has the greatest number of digits after the decimal point. The first coefficient has 1 digit after the decimal point. The whole number 2 has no digits after the decimal point. The third term has 2 digits after the decimal point. And the fourth term has only 1. So I'm going to focus on this third term. In order to make this an integer, I would need to multiply by 100. This would move the decimal point 2 places to the right, and I'd be left with an integer value. So I'm going to multiply both sides by 100. I'll distribute, and 100 times 1.6x is 160x, and notice I move the decimal point 2 places to the right. 100 times 2 is 200. 100 times 0.05x is 5x, and 100 times 10.4 is 1040. Now I've cleared the decimals. I'll subtract 5x from both sides, get 155x plus 200 equals negative 1040. I'll subtract 200 from both sides to get 155x equals negative 1240. Now I'll divide by 155, and this gives me negative 8. We get the same answer, but the equation is solved and not have decimal coefficients.
All right. Okay, so we have decimals out here and here, because that one has a thousandth place or a hundredth place. Multiply everything by 100. So 100 times 0.2 is 20. 100 times 0.45 is 45. 100 times 12 is 1200. Get rid of the parentheses. 20x plus 80 minus 45x. What's 9 times 45? let's see, 9 times 45, 405. There we go. All right, let's combine our x's here. That's negative 20, wait, negative 15, isn't it? Wait, no, negative 25x, yeah. Then combine these, 405, 80, this gives me a negative 325. Let's add 325 to both sides. Be 1525. So x is negative 1525 over 25. Whatever that is. 1525 divided by 20, 61. All right. This one we can do in the same way. Since there's hundredths places, multiply everything by 100. We get 25 times x plus 2 minus 15 times x plus 3 equals 400. Okay, let's get rid of the parentheses. 25x plus 50 minus 15x minus 45. Combine our x's. 25 minus 15 is 10. 50 minus 45 is 5. Subtract 5 from both sides. Divide both sides by 10. X is 39.5. That's it for 10.3. Make sure you do your homework for 10.3. And Alex, now we need to go to, what was it, 10.6? Yeah, skipping to 10.6 now. Oh, the hell. 10.2, 10.3, 4, 5, 10.6. Okay, let's see here. All right. Excuse me. A literal equation is an equation that has more than one variable. Okay, I've never heard of that before, but I guess that's what they call it. So, like this, the formula for the perimeter is the sum of the lengths all the way around the sides. Lady has to say.
To find the perimeter of a triangle, we add the lengths of the sides. As a formula, we can represent this as P equals A plus B plus C, where A, B, and C are the lengths of the sides. Notice that the variable P is isolated, and I can substitute 5 inches for A, 6 inches for B, and 8 inches for C. This gives us the perimeter of 19 inches. So what if we already knew the perimeter of a triangle? Say we have a perimeter of 32 inches. Furthermore, if the lengths of two sides are known, we should be able to find the length of the third side. In the figure, side B is 10 inches, side C is 15 inches, and side A is unknown. So I want to solve this formula for side A. That is, I want to isolate the variable A. Since the variables B and C are being added to A, I'll reverse this operation and subtract B and C from both sides. I have P minus B minus C equals A plus B plus C minus b minus c. So now we have p minus b minus c equals a. And I'll write the variable a on the left-hand side. So a equals p minus b minus c. So now I'll enter 32 inches for p, 10 inches for b, and 15 inches for c. This gives us a equals 7 inches. The length of side A is 7 inches. Now I want to point out with the formula, a equals p minus b minus c represents the same relationship among the variables as the original formula. All I did was rearrange the formula to solve for a different variable.
Okay. Solve for t. Oh, here's t. Let's get that r off of its back. So we have t is d over r. You can see basically we're just going whoop, right? Over here we need to get y by itself. Let's move the 5x over. And now we can divide both sides by 2. Right? 6 and 5 halves. Okay, does that make sense?
In this video, we have the formula v equals IR. We need to rearrange the formula and solve for the variable r. That is, instead of having v over here by itself, we want to isolate r. Since the variables I and r are being multiplied, we want to reverse this process and divide both sides by I. We have v over I equals IR over I. And this simplifies to v over I equals r. I can rewrite this with a variable r on the left-hand side. R equals v over I. This formula is expressing the same relationship among the variables as the original formula. We've just rearranged the formula to isolate a different variable. So if we're given values for v and I, we can easily find r.
All right, if we want L, we have to divide both sides by W. So L is A over W. Here, if we want A, move the 4B over. We have negative 2A equals 7 minus 4B. And now we divide both sides by a negative 2. 7 over 2. 4 over 2 is 2.
In this video, we have the equation 3x plus 4y equals 8 and we need to solve for y. That is, we want to isolate the y variable. So first I want to isolate the term containing y. So if I add the opposite of 3x to both sides, that will remove the term 3x on the left. We have 3x plus negative 3x plus 4y equals negative 3x plus 8. Notice on the right-hand side, I wrote the negative 3x term first, in front of the constant term. I did this because it's conventional to write the variable terms first, followed by constant terms. That being said, if you wrote this as 8 plus negative 3x, that would also be completely correct. Simplifying, I have 4y equals negative 3x plus 8. At this point, I want to get a coefficient of 1 on the y term. So I'll divide both sides by 4. Notice that the division bar on the right extends over both terms, negative 3x and 8. That is, both terms are being divided by 4. So we have y equals negative 3x plus 8 all over 4. Now we're actually done. We've isolated the y variable, but you might be tempted to try to cancel the 8 and the 4 here. We're not allowed to do that because the 4 in the denominator is actually dividing into both terms in the numerator. We can't just strike through the 8 and the 4 because the 4 is also dividing into the term negative 3x. So instead, what we can do is rewrite this as y equals negative 3x over 4 plus 8 over 4. In other words, I've written a big fraction as two separate fractions, and in each case, the division by 4 is maintained. This now simplifies as y equals negative 3/4 x plus 2. So we actually have two ways we can express the final answer, and both are correct.
All right, so this formula converts Fahrenheit to degrees Celsius. So what do they want us to do? Solve for F. See, this way I can plug in a temperature in Fahrenheit and the formula gives me the degrees in Celsius. What if I want to turn it around? What if I want to have F equals some stuff with C's in it? So let's invert this thing here. First thing, I want to get rid of this 5/9. If I multiply both sides by 9/5, 9/5 times 5/9 cancels out. So I have 9c over 5 is equal to f minus 32. I just need to add 32 to both sides. So f is 9c over 5 plus 32. Here, if we want to solve for x, let's multiply both sides by 3. Oh, look, I already did. Multiplying both sides by 3. So I have 3y equals x minus 7. We'll add 7 to both sides. And we are done.
In this video, we have the formula d equals 5/4 times the quantity p minus r. We need to rearrange the formula to solve for p. Well, I have two choices as to how to begin. I can clear parentheses, or I can multiply both sides by the reciprocal of 5/4. That would make the right-hand side much simpler. So I think I'll do that. I have 4/5 times d equals 4/5 times 5/4 times the quantity p minus r. The purpose of doing this is to eliminate the fraction on the right-hand side. So we now have 4/5 d equals p minus r. At this point, we can just add r to both sides, and this gives us 4/5 d plus r equals p. I'll write p on the left-hand side, and p equals 4/5 d plus r. We can also approach this problem by first clearing parentheses. We have d equals 5/4 p minus 5/4 r. Now I'll isolate the term containing p. I'll add 5/4 r to both sides. So d plus 5/4 r equals 5/4 p. Now I'll clear fractions by multiplying both sides by 4. So we have 4d plus 5r equals 5p. To get a coefficient of 1 on the p term, I'll divide both sides by 5. Simplifying, we get 4d plus 5r all over 5 equals p. This is an acceptable answer. We've solved for p as the directions indicate. However, the two answers don't look the same, and this can present a problem for students. Sometimes students will get this answer, which is correct, but the answer given in the book might be this answer. So we can do what's called form fitting to show that the two expressions are equal. For example, I can write the big fraction here on the left as two separate fractions. We have 4d over 5 plus 5r over 5 equals p. Now when I simplify, we get p equals 4/5 d plus r. So now we see that the two expressions match.
Okay.
The perimeter of a picture frame is 44 inches. If the length is 2 inches longer than the width, find the dimensions of the frame. To begin, drag the lower right corner of the rectangle until the dimensions of the picture frame meet the conditions of the problem.
What? 40, if the length is 2 inches longer than the width. All right, so dang it. There. Yes, it is. Oh, look at it. It wants to do the other way. So length. Which one's the length? Oh, it wants to do with 13. There. Well, what the hell? The perimeter. Oh, the perimeter has to be 44 inches. Okay. So let's see if we did what 20 20 and 22, no. 21 and 23, right? All right, so well, it only goes up to 16. Oh, that's right, because it's 4 times around. So 21 and 23 divided by 2 would be 10 and a half. One of them has to be 10 and a half, and the other one has to be 2 more than that. That would be 12 and a half. Well, God damn it. Right, 10 and a half and 10 and a half would be 21. And then 12 and a half and 12 and a half would be, still too big. That would be 25, right? 25 and 21 would give me 46. I need to make these an inch shorter. Try 9 and 11. No, 9 and a half twice. Should have to do the math. All right, if we have x and y, we know that twice x and twice y needs to be 44 inches. But we also know that what x minus 2 has to be y, so that y is 2. I guess I should use width and length, right? W and L, and they want the width to be, I add 2 to the width, I get the length. Right, so we have 2 equations with 2 unknowns. How do we solve this? Well, L is W plus 2, so if I take the L here, if I replace the L with W, replace the L, so I have a 2 in front of L, and L is W plus 2. Okay, so I just took the L here and I replaced it with this. So now there's only W's, and we can solve. We divide everything by 2. I get this. W and W is 2W. And divide everything by 2 again. The W needs to be 10. If I have 10, 10, and that would mean since W is 10 and L is W plus 2, L has to be 12. 12 and 12 is 24, and then 10 and 10 gives us our 44. There we go. There we go. So 10, 12. Haha. All right. That was fun. So we're on what, 10.6? So start doing your 10.6 homework. Let's call it a day. Have our exam. This is number 12. Yeah. Solve for x. I have 3 halves times x minus 1 plus x equals x plus 2 over 3 plus x. Let's say I have 5, 6, a plus b plus c equals, I'm going to put an x here, plus x equals 3x plus 2 times a minus b. So we don't know what a or b is, you just leave them in the equation, okay? So you're going to end up with x equals some stuff with numbers and A's and B's. Okay? Can y'all handle that?
Yeah, I can try it.
So let me give you an example. If I had x a plus x equals b plus 3, right? Well, I would subtract a from both sides, and I would get x equals b minus a plus 3. And that would be the answer. We just don't know what b and a are. So basically you want to get rid of the fractions here, and then get your x's together, consolidate your x's, and then throw everything else to the other side of the equation. Right, does that make sense?
Could we multiply the entire number by a similar number? So like, for example, I don't know, 18,
I'd multiply everything by 6 to get rid of that.
6. Oh, that's true. Yeah, you can multiply 3 by 6. Okay, perfect.
The same
And then
thing,
the top one, you can't multiply the
I can multiply
fraction, right?
everything.
Or you could, yeah, never mind.
You'll have 6 times this, 6 times this, 6 times this, and 6 times
Mhm.
that.
Perfect.
So,
Cool. Thank you.
yeah. Folks, I'll see y'all Tuesday.